Okay, now I'm going to do section 2.6 on applying the trigonometric ratio. And specifically, we're going to look at, in this example, solving a triangle. And that means that we are going to find all of the sides and all of the angles on a given right triangle. And to do this, we can use any or sometimes all of the three primary trigonometric ratios, that is sine, cos, and tan. And so I have a couple of tips for you. Please write this down. Actually, I'm going to type it this time. So, tip, list and all the angles, so you know what you have to find. So that means that for this triangle, I would say I need to find angle P, I need to find angle Q, I need to find angle R, I need to find side P, I need to find side Q, and I need to find side R. So the first thing I'm going to do is list all of those so that I know that I need to find them all. Well, some of them I will already have, but I'll fill those in. You'll see that in the example. Okay, my second tip, tip number 2, when use provided numbers in your calculations rather than values you have calculated. I've talked about that in class a little bit. If you make a mistake calculating, for example, angle Q, and then you use that to calculate something else, everything you do from that point will be wrong. If you can do all of your calculations from the numbers that are originally provided to you, you've eliminated that source of error. And then when you come to my tip number 3, check your answers using you did not use in your calculations. Okay, that's my third tip. So I'll show you that in the example. So let's go to the next page. So solve this triangle. So to solve this triangle, when I'm finished, I will have angle K, angle K equals angle M, oh my goodness, let's try that again. Angle M equals angle N equals, I will also have a value for side K, side M, and side N. Now right now I actually have, this is side N, this is side M, and this is side K, because remember we labeled them with the letter of the corner, the vertex at their opposites. So I actually already know that angle M is 90 degrees, and I know that side N is 7.0 centimeters, and I know that side K is 11.0 centimeters. So the first thing I'm going to do, and you can do this in any order you want, but I'm going to do it, do side M first. So I'm going to come up here, because I like to keep my work neat, I'm going to do angle M, and I'm going to use Pythagoras for that because I have two sides and it's a right angle triangle, so I can do that, and that's the easiest way to do it. So I can use Pythagoras. So my base equation, a squared plus b squared equals c squared. When I translate that to this triangle, my c squared is always the hypotenuse, so that is m. And this can be n squared plus k squared. Then I will plug in my numbers, so this becomes 7 squared plus 11 squared equals m squared. And then m squared, this is 170 equals m squared. get my magic algebra pen so that I'm showing that the next step is I'm taking the square root of both of those, and I'm left with m equals 13.0. Dims, does that make sense? Is that a reasonable value for this side? 13.0? I would say so. So let's put that in over here. 13.0 centimeters. Okay, the next thing I'm going to calculate is angle K. And it is really a good idea to make a note to yourself. Use your words, use your letters, use something to say what it is you're looking, what are you working on? So I'm going to write out my SOHCAHTOA. And I'm talking about angle K. So I'm looking for the angle, which means I'm looking for either the sine or the cos or the tan, because if I can find one of those, I can find the angle. And I know the adjacent, so I'm going to circle the A's. And I know the opposite, so I'll circle the O's. And now I know that I'm going to use tan. So my base equation, tan theta equals opposite over adjacent. Tan K equals 11 over 7. And K equals, that works out to 57.5 degrees. Actually, just going to make sure you don't think that's a 1. Now, there is more writing in this that I have done previously where I would have gone tan to the minus 1. Actually, I can put that in. Put the tan to the minus 1 on this side. And tan to the minus 1 on this side. But at this point, I'm assuming that you know how to do that. If you need to write it, by all means write it. There's things that I do every time, even though you'd think as a math teacher I wouldn't need to do that, but I still do it every time. Because I know that I tend to make mistakes in that particular spot, so I write it out. Each decision after you've done a bunch of questions. Anyway, we're back to K, which is 57.5 degrees. I'm going to scroll down a little bit. We still need to find, see how easy it is to look at and say, oh, well, I haven't found angle N yet. One answer they're looking for. So if you have a way of keeping track of what information you're ultimately after, it's a good thing to do that. Okay, so we have, we go SOHCAHTOA. And some of you by this point won't need to write this out, but if you need to write it out, you need to write it out. That's fine. So I'm going to box the S because I'm looking for the angle. I'm looking for the sine or the cos or the tan. But for angle N, oh, I still know the opposite and the adjacent. So I know the opposite. And I know the adjacent. Oops, this is supposed to be TOA. There we go. So I'm going to use tan again. So tan theta equals opposite over adjacent. Tan N equals 7 over 11. Just scroll down a bit more. I'm going to run out of space for you to see it. And I'm going to put N equals, so I'll come write that up here, 32.5 degrees. And then we need to check our work. So check angles. Well, what I know about the angles is that K plus M plus N need to equal 180 degrees because this is a triangle. So if I add them up, K is 57.5 and M is 90 and N is 32.5. Yep, that equals 180. So that's good. Okay, then I need to check the side. Oops, I need a pen. Check side And I've already used Pythagoras, so I don't want to use Pythagoras. I'm going to use cos. I'm actually going to use cos of n to check the side. I know that cos of theta is adjacent over hypotenuse. So cos n is 32.5 degrees. So cos of n is 11 over 13. And then I just get both of those numbers in decimal form. So cos of 32.5 is 0.84339, and 11 divided by 13 is 0.84615. Those the same number? I'm going to say yes, those are close enough. We will have some rounding errors because it's not exactly 32.5 degrees. It's 32, rounded to 32.5. So this is definitely close enough. So that's solving a right triangle. Example 2, that was when we were given two sides. Checking it or solving a triangle when we were given different information. Really follow the same process, but I'll do another example for you. Again, the first step, always, because you want to make sure you've answered the question, angle G equals, angle H equals, angle J equals, side G equals, side H equals, and side J equals. And this is my side H, and this is my side G, and this is my side J. So I know that angle G is 90 degrees, and I know that angle H is 39 degrees, and I know that side H is 9.0 centimeters. So the first thing I'm going to calculate, I always go for the easy one first, so I'm going to find angle J. And what I know is that H plus J have to equal 90. So J equals 90 minus H equals 90 minus 39, which equals 51 degrees. So angle J is 51 degrees. Next thing I'm going to calculate is side G. And it doesn't matter whether you do G or J first. Just happen to do G first. So I'm going to do my SOHCAHTOA thing because that just works so well. SOHCAHTOA. So for angle G, side G. That is the hypotenuse. So I'm going to box the hypotenuse. And then I have to decide which angle am I going to use. And I'm going to use angle H because I know for sure that that is 39 degrees. J I'm pretty sure about, but I know for sure that H is 39. So in order to not compound any error I've made, I will always use the angle they give me. So I know the angle. So I can circle sine, cos, and tan. And I also know the opposite of that angle, so I'll circle the O's. And this tells me I'm going to use sine. So sine theta equals opposite over hypotenuse. Sine of 39 equals 9 over G. My magic algebra pen, I need to multiply this side by G, which cancels out. I need to multiply this side by G. And then I have G sine 39 equals 9. Oops, I meant to change pens. I'll use my green magic algebra pen this time. I'm going to divide that by sine 39, and I will divide this side by sine 39. And I'm left, those cancel out. I'm left with G equals 9 over sine 39, which my calculator tells me this is 14.3. Dims, does that make sense? Looking at this, if that's 9 is 14. That seems reasonable to me. So put 14.3 for side 3. And then we need to figure out side A, because that's what we don't have. Yep. So for this time we're going to use angle H again. Right? Same reason. We still know that that's the one that we know. So we know sine, we know cos, we know tan, and we know the opposite. We know the opposite. And this time what we're looking for is adjacent to angle H. So we're going to use tan. So tan theta is opposite over adjacent. Tan 39 equals 9 over j. Have to multiply this side by j, to multiply this side by j. Need to scroll down. We have j times tan 39 equals 9, because those j's have canceled out. Now I need to divide this side by tan 39, divide that side by tan 39, those cancel out, and I'm left with j. And j equals 9 divided by tangent 39, and j equals 11.1. Oops, the red pen dims. Let's go back to our triangle. So this side here is 9. This side here is 14.3. Is 11 a good number for that? Yeah, I would say so. So that's 11.1. So are we done? Not quite, because we should take the time that it takes to check this answer. So we're going to check the sides using Pythagoras. And oops, j squared, let me fix that. J squared plus h squared equals g squared. 11.1 squared plus 9.0 squared equals 14.3 squared. So on the left side I get 204.21, and on the right side I get 204.49. And again, oops, this is close enough. We know that we're going to have rounding errors. We know that it wasn't exactly 11.1, it was 11.1 something. Okay? There we go. Okay, example 3 is using trig to solve a problem that's not just a made-up problem. This is actually something you might need to do if you were building a fancy window in your house. The window has a shape of a regular decagon. Deca means 10, so it means it's a 10-sided window. And regular means that the angles and the sides are all the same. So each of the 10 sides, let's count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each of the sides is the same length, and all of the angles between them are all the same. So we have some symmetry going on for us here. The distance from one vertex to the opposite vertex measured through the center of the window is approximately 4 feet. Determine the length of the wood molding material that forms the frame of the window to the nearest foot. Now, big clue is we're using trig, so we need to find a triangle. And specifically, we need to find a right triangle. So the triangle that I see goes from this vertex here to the center of the window. And there are actually 10 such triangles, right? And they're all going to be the same because the angles and the sides are all the same. So I'm going to draw that triangle again down here. Now, okay, so it's not a great drawing of the triangle, but and then I know that this side here is 2. Whoops. This side is 2, and this side is also 2. But we need a right angle triangle. This, though, is an isosceles triangle, right? Because if I look up in here, this angle and this angle are the same, and any isosceles triangle can be split down the middle. That's the middle, right? To make 2 right angle triangles. And this side, if I label my triangle, so that I'm going to call this A, B, and C, this side B is now half of one of this distance here, right? So if I can figure out B, I know that my perimeter, because that's essentially what we're looking for, perimeter equals 20 times B. Okay, that's easy. Just need to find B. So one technique that I will show you again and again this year is, this is my big picture sentence. I need to find I know that perimeter is 20 times B. I don't know what B is. So I'm going to tab in. Can't find my pen. Okay, sorry. I'm going to tab in and I'm going to find B. By tab in, I mean I'm going to leave some space here as a visual reminder to myself that when I find B, I'm not finished. I need to go back up a level and use B. Okay? You'll see what I mean when I get to the end. So I need to find B. So now I have a triangle. I know that there's a right angle and I need to figure out another angle. So there is some formula that will actually tell me what this angle is, but I can never remember it. What I do know is that a circle is 360 degrees. And this whole angle is 1/10 of a circle, right? That's 1/10 of a circle, and that's 1/10 of a circle, and that's 1/10 of a circle. So my angle B, angle B equals 1/20th of a circle. So B, 1/20th. So B is 1/20th of 360 degrees. So angle B is 18 degrees. So this angle right here, is 18 degrees. Okay, so now I know enough about this triangle to find B. So I'm going to do my SOHCAHTOA thing. SOHCAHTOA. I know the angle, so I know sine, cos, and tan. I know the hypotenuse, which is 2. And what I'm looking for is the opposite side. Circle the O's. So I'm going to use sine. So sine theta is opposite over hypotenuse. Sine of 18 degrees is B over 2. So B equals 2 sine 18. So B equals 0.618. And I will actually leave the full value of that in my calculator. I'm just only going to write down that. Okay? And then, because I tabbed in here, I have this visual reminder that I need to do something with B. So I look back up my screen, and it says perimeter equals 20B. So I can rewrite that down here. Sometimes I will, sometimes I won't, but I will today. Depends how complicated it is and how long it is since I've looked at it, how much calculations I've done since then. So it's 20B, so perimeter equals 20 times 0.618, which equals 12.36 feet. So my answer, because they asked me to round it to the nearest foot, is 12 feet. And there's my answer. Now I need to ask myself if that's reasonable, so let's go back up to our drawing. Okay, if this whole distance is 4 feet, half of it's 2, and if that's 2 feet, this looks like, what, a little more than 1 foot? A little more than a foot? And there are 10 of those, so a little more than 10 feet, 12 feet, works for me. Okay, so we're done. Go do your homework. No, don't go do your homework. Finish writing your notes up and come to class ready to do homework next day. Bye-bye.